Here's a little bit of a surprise. Now you can do it if you like. Oh, you did? Oh, okay, perfect. Okay. For those of you listening at home, hi, man. We will launch forward with notes. I was gone yesterday because I was iced in Ionia.
Wait, you live?
Say no homework.
I live an hour away, yeah.
Yes, we
No,
do.
that's
We're not discussing that now, we're discussing this. Go ahead and write this down. It does require a notebook out.
Wait.
Not everybody has them out. Yes, sir.
Does this say 1.4?
1.4, correct. 1.4 repeating.
Yeah. I thought it said like 1.
So the 1 is not repeating, the 0.4 is. So in case there's any doubt, this is like 1.4444, blah, 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 blah. Make sense? And my question is, can we make this into a fraction? Okay, whisper please. Gentlemen, this is not boding well. If you're chit-chatting that much now, it may be worse later. Yes, ma'am?
Yes, you can turn it into a fraction.
You should be able to turn it into a fraction. By the way, there are 2 types of decimals that are guaranteed to be fractions. What 2? Give me 1. 2 types of decimals that are guaranteed that you can convert them to fractions. Another word for convert to fraction is they are rational. Go.
Repeating and terminating.
Repeating and terminating. Repeating just means it repeats. What does terminating mean?
Like it ends at a certain point.
It just ends. Correct. This doesn't end, but it does repeat. Repeating decimals have to be a fraction. Ending decimals have to be a fraction. Anything else does not have to be a fraction. So the question is how? So we know there must be a fraction for this, but how do we get it? Yeah, I did.
Can you do 1 plus 4 over 9?
Ah, clever. 1 plus 4 over 9. So remember from the other day, how do you get something to repeat? You.
You you multiply it by 9. No, that is
Other way around.
You divide it by 9.
Divide by 9. So if I want to do like 0.2 repeating, what's the fraction for that?
2 over 9.
Give me a check. 2 over 9.
No.
Can anybody give me 0.181818? Blah, 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 blah. What fraction is that in? Not the point though. 1/8 over 99. Does that make sense? Now, one little catch on that one. That reduces. Rob, what is 18 over 99 reduced by? What goes into both of them? 9. How many 9s are on top? How many 9s on the bottom? 11. Okay. Let's not have discussion and arguments and rudeness like that. Okay? Not a place for it here. Do be aware, 2 over 11 is not obviously a repeating decimal, but 18 over 99 is. If the bottom is full of 9s, the top is going to repeat. Now, sometimes, well, can somebody tell me what the 4 over 9 would be? 1 plus what as a decimal? What's 4 over 9 as what? 0.4 repeating. Sure enough. Now, can somebody go all the way and give me an improper fraction? What's 1 4/9? Go.
Would it be 1 and 4/9? No.
True.
Would it be wait?
Keep going. Remember the trick?
20? No. What?
How do you get a mixed number into a fraction?
You I know how to do it. I don't know how to explain it. You
Okay, go for it. Just do it.
The okay.
What's
so,
the final answer?
Oh gosh. Would it be 18 over? No. What? No.
A little too big.
Equal 2.
It's going to be over 9.
Yes, over 9. 13.
Ah, there you go. How do you get 13?
9 plus 4. Oh yeah, the one is basically.
Yeah, 1 times 9 is 9 plus 4. 13 over 9. So 13 over 9 gives you 1.4 repeating. That would not be immediately obvious. People would expect it'd be 1.3131313. They'd expect the 13 to repeat. But remember, 13 is 2 digits. Well, people say, all right, fine, it should be 1.33333, not the 1.44444. That's weird. Why did the 4 show up? Because this is not 1 3/9. It's 1 4/9. So you actually have to get it into a mixed number, curiously. Now, I usually don't like mixed numbers all that much, but a mixed number will help you find out what's actually repeating. So if you have like a number in front that's not repeating, split it off. So split it off, kind of like we did here. That's kind of the key. Does that make sense, Scott? Then the other part should be easier. So there's topic number 1. What happens if you have a whole number attached to your repeating decimal? Split the whole number off, add it to the other part. That's pretty much a standard trick. Now, standard trick number 2. This is, by the way, the repeating decimal algorithm. What in the world is an algorithm? Have you ever heard the word before? If you're into sci-fi, you probably heard the word tossed around. It's an algorithm. It's actually a computer science term. Algorithm means a step-by-step process. It's a logical step-by-step process that you can just do over and over and over. So technically, when I come in the morning, like I come in at 7, and there might be 1 or 2 people who arrive here before I do, but I'm one of the first people here. And like Mr. Good usually beats me, and then there's usually somebody who beats me, I don't know. But there'd be somebody's obscure light on, and I say, I wonder who that is. I still don't know. But Mr. Good comes in, yeah. He and I sometimes beat him. But my usually thing is I go in the front door, I beat the security thing open, and then I turn on all the lights because I'm the first one in. So click on the light for the first hallway, click on the light for the lower hallway, unlock the doors, prop them, go up the stairs, go to the second floor, unlock those doors, prop them open. Why? Because I'm a nice guy. You're welcome. And turn on the lights there, and then go up to the third. Every single day. Saying, unless somebody beat you there, that's my routine. That's my algorithm. It's step by step, which does the same thing over and over and over. That's called an algorithm. Now, a repeating decimal algorithm, that means there is a guaranteed way to take any repeating decimal, nice or not nice, and convert it into a fraction. Now, it might be a little weird, I'll warn you. Step 1. Let's see. Let me see. Split off any whole number. Kind of like what we did here. If there's any whole number, just split it off. Does everybody have this down, the 1.4? I need some space. We can do another one like that in a minute. So let me run an example while we're doing it so you can see, like, in the physical world what's actually happening here. I'm going to do 2 point, this is going to be a little weird. 0, 3, with just the 3 repeating. This, we have never done a problem like this before. This is one where they don't start repeating until a little bit into the decimal. That's just weird. It's not 030303. This is 2.03333, blah, blah, blah. Which is really weird. All of our techniques that we have so far don't know how to handle that. So our first step is split off the 2. 2 plus 0.03 with the 3 repeating. Just do that. You do that and I think you're 20% of the way done. Second, this is kind of it's almost a math joke, but does anybody know what 0.03 repeating is as a fraction? Off the top of your head. I hope you're saying, what?
3 over 99. No, I know, 3 hundredths.
What that?
No, no, what?
0.03. 0.03 would be 3 over 100.
3 over 99.
3.33, what was that?
3 over 99.
3 over 99? Maybe. We'll find
3
out.
repeating over? No, no.
That would be 0.303030303 with a whole bunch of extra zeros. Not this. Nice try.
3 over. Nice try.
So in other words, we don't know. I don't know. I have the foggiest idea what it is. So, what do you call something you don't know? Oh, algebra people.
What? X.
X. A very good.
I knew that. Oh, yeah.
Name the repeating part. X. Now you don't have to use X, you can use Q or whatever variable you like. But X is kind of the universally beloved variable. So, is everybody clear so far? Basically, we don't know what it is, so we're gonna call it a variable, we don't know. So over here, step 2, we're gonna say X equals 0.03 repeating. We haven't done much, but that's gonna set us up to solve the problem. Step 3. Multiply both sides by, this is going to be kind of big, a big enough power of 10 to get past the non-repeating part. Now put in parentheses, if necessary. Sometimes there isn't any extra thing, like a 0 that's not repeating. If you were just plain old 2.3 repeating, you could just skip step 3. This is to get past the dead weight there, so to speak. So multiply both sides by a big enough power of 10. Is everybody clear what a power of 10 is? Like 10 to the first power is 10 to the second power, 10 to the third power. So power of 10 is kind of like 10 or 100, bless you, or 1,000, and so on. So some sort of power of 10 that's big enough to get past the junk, the non-repeating stuff. Okay? Let's do that. What power of 10 do you think would work here? How big of a power of 10 do we need in order to get past that 0? Trust. How many spaces do we have to skip in order to get past the 0? 1. What would we multiply it by to do that? 10. Yeah, we don't need a heck of a lot. Now you can do it as long as you do it to both sides. So it'd be 10x equals, let me know what this would look like now. Go.
Would it be 0.3?
Yeah, it's 0.3 repeating. So you go past, this is 1. So you move the decimal 1 space to the right by multiplying by 10 on both sides. That actually got us a genuine repeating decimal. Like that's kind of what we're used to. So 10x equals that thing. Yeah.
We're still trying, yeah, we're trying to make it a fraction, right?
Correct. Yes. Step 4. Multiply both sides. Again. By, excuse me, phlegm attack. By a big enough power of 10. What am I doing? That's OT. Of 10. Right? And listen. So multiply both sides again by a big enough power of 10 to get past 1 repeat. It's a little easier to see if you write it like this. In other words, how many digits are, you all know what a digit is? Like a single number, 1, 2, 3, 4, 5, those are digits. How many digits are repeating in this problem? How many digits are being repeated over and over and over? Aaron? Just one. There is one digit repeating. One digit is repeating. If this were 0.323232, I'd say there were 2 digits repeating. Does that make sense so far? So step 4 is, I want to multiply further by another power of 10, enough to hop over one repeat. Now one repeat is just one more space. So Maria, how much more do we have to multiply by to scoot it over and capture one repeat?
10.
Another 10. We're going to multiply by another 10 as long as we do it to
Both sides.
both sides. So we're going to do times 10 here and times 10 here. What does that make this?
100.
100 x.
Squared.
Not the x, sorry, I should have done
Oh, okay.
a dot for times 10. I just didn't want to look like a decimal. So times 10 times 10. What does this look like now that you scooted it over?
3.3 repeating.
Yes, 3.33333. Does that make sense? That's actually the key step in the whole thing. If you can get this, you're 80% of the way done. Everybody clear?
Can you just skip step 3?
You can skip step 3. Step 3 got us over the 0.
Yeah, but can you just multiply it by 100 and know that it would be 3.3?
I wish. You cannot. Now I'll show you why in step 5. Yeah.
Why is it step 3?
I tried that in the past, by the way, and I crashed and burned. Because I had the same idea. Go ahead.
Why isn't the first 3 repeating?
Why isn't the first 3 repeating? It sort of is. I'll just write it the way it is now. This is 100x equals 3.3333. You just captured the first one. The 3's are still repeating forever. You just grabbed the first 3 and moved it to one side. Does that make sense? Is this repeating? It's one of the repeats. It's sort of like saying, is this 3 repeating? Well, depending on your point of view. It's just an infinite number of 3's. This just happens to be one of them. And this just happens to be one of them. I just captured the first one. But the other 3's are going forever. So in a certain sense, this 3 is alone. But the other 3's are going forever and taking up the job. Does that make sense? I hope. Yeah. Trust.
What do you do with the 2?
I'm sorry?
The plus 2.
Oh, with the plus 2. We're going to bring that back at the end. Yeah, we're not going to forget it. So I'm just, this part was easy. What does 2 equal to? It's 2. But this, so I want to make this a fraction, then we'll do a mixed number, and then we'll do an improper
So
fraction.
you add the 2 to the...
When we're all done, we'll add the 2 to it. Yeah.
Okay.
So here's the tricky trick. Step 5. Subtract step 3 from step 4. I guess there's 7 steps on this thing. What in the world does that mean? Subtract step 3 away from step 4. Here's what it looks like. Step 3 is this. Step 4 is this. You gotta watch carefully on it because A, you could kind of miss it if you're not paying attention, and B, it is one of the coolest math tricks in the world. In my humble opinion. Here's 4. Remember, you can do anything you want as long as you do it to what? Both sides. I want to subtract 3 away from 4. Does anybody see what's about to happen?
Equals.
First of all, what's 100x minus 10x? Anybody? It's not too hard.
0. No 10.
Go ahead, John. 90.
I really don't.
X equals, here's the tricky part. If you can get this, the whole problem cracks open. What's 3.3 repeating minus the 0.3 repeating?
3.
Go. You're on the right track. There's something left.
3.
3.
Even I knew that.
Yeah,
He said even.
What have we been talking about as far as being nice? Practice.
He said point.
That was
He
anti-nice.
said 3.3.
Now, algebra people, step 6. Solve for x. Do it. Rosie, take over. Get x by itself. What do you have to do?
Divide 90x by 90,
Yep, as long as you do it too.
both sides.
Go for it. X equals
3 over 90.
3 over 90. Does that reduce?
I don't know.
What number goes into both?
Oh yeah, it does divide by 3.
3. So how many 3's on top?
1.
One.
And then 30.
Got it. By the way, you know way back up here, you had said that unknown thing, we have no idea what it is, we call it x. It's not unknown anymore. You just found it. Step 7. Add x to the whole number and simplify. So what does that mean? Here's the original. It was 2 plus x. That's the x was the thing we didn't know. So what is that really? 2 plus what? Yeah. What was x we finally found out? What fraction did we finally get? 1 over 30. This is 2 and 1/30. Can you give me an improper fraction for that? What's the trick for that? Yeah, sorry, go ahead, bending underneath this silly thing. It was a trick we did earlier. Yes, 2 times 30 is, and then plus 1 over. Congratulations, on math people, you have just conquered an extremely tough repeating decimal problem. By the way, anybody have a calculator? Type in 61. Do 61 divided by 30. See what you get.
61 divided by 30.
2.03 repeaters.
Ding 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 ding. Go.
Whoa.
Can you just start, like, the first one, just divide 3 by 90? Like, just start.
Oh, could you divide 3 by 90? Yes. You get 273 over 90, and you'd have to reduce it anyway.
But I mean, like, instead of doing stuff like 2 through 5, maybe you just start with, like, dividing by 90.
Oh, you're wondering, like, does dividing by 90 do something special? Yes and no. If there's no whole number attached, which is why we split it off, if it's just something smaller than 90 on top, yes, it does work. I'll give you a caution. Tell you what, if you don't have a calculator, this is one of the rare times I'd like you to use one. Does anybody need one to borrow? I have loads of them. I find them at the thrift store for like $2 or $3 each. It's totally fun. Nobody knows the values of these but us now. So, yeah, it still has the sticker of the $1. Yeah, so. I do need these back. There you go. No problem. Anybody else? Okay, good. So make sure you get these back to me. Anybody else? Need oh. Anybody else? Okay, familiarize yourself with where this. First of all, where the on button is. It's lower left.
Stop.
The off button is lower left as well. You have to hit the shift key.
It's gonna find a button.
Brendan, I did find it, okay?
All right. Let's try this.
I know, and it's easier to close from outside. I wasn't even meant to be sold.
People listening at home, howdy.
But I stole it from a store, because why not?
Take your calculator at home if you have one. Ladies and gentlemen. Go, quick question.
Don't trade calculators if
Are you serious? No. It's all right. Shouldn't you trade calculators? No, it's mine, thanks. I mean,
Sure.
Now, by the way, I got this for $3 at the same thrift store.
What?
They apparently did not know its value. These cost like $100. But
That's so.
See,
Anyway.
I feel bad, okay, evil.
no. They can price these things whatever they want. I didn't force them.
That's so.
No. So yeah, but if we wanted to get it on eBay, it's like 30, 40, 50 bucks. So that was a bonus. Now, we tried this out. So we got 61 over 30, and yeah, it's 2.03333 repeating. Question was asked. The question was asked, what happens if you divide something by 90? The answer is it depends on how big the thing is. If the thing, where's my marker? Oh, there it is.
This says advanced business it is. Advanced.
So let's try this. 29 over 90. Type it in. Just as an exploration.
What? 0.32. Wait, what is it?
29 over 90. I'm just curious what it gets.
Wait, what is it again?
29 divided by 90.
0.32 divided by
0.32222222. That's weird. It looks like it has absolutely nothing to do with. I was expecting 0.02929, you know, that, or 2999999. Yeah, question. Okay. So what in the world? Why is that? Well, I'll show you a couple things. First of all, does everybody have this? I'm trying to figure out a place to erase.
Can you write this down? Oh my god.
This stuff?
No, the
This-
thing you're gonna show us.
Yes, that would be good.
Will we need it on a test?
It's short. What's that?
Will we need it on a test?
It would be, on a test, there's usually like 3 or 4 different ways to do the same problem. If you have all 3 or 4 ways, this method might be easier sometimes. That method might be easier sometimes, so it's kind of up to you. If you only have one technique to solve any math problem, that's sometimes called being a one-trick pony, you can sometimes get really stuck if you got a problem that's super duper weird, where another technique you could do it in 10 seconds. Like, you know when you're doing algebra or complete the square? There are people who, in my previous school, they did complete the square for everything. They solved it by, I mean, complete the square is nice. I'm a fan of complete the square. But
I don't even know how to do that.
you know that some of those that factored by unfoil, you can solve them in like 10 seconds. You know, like this, x squared plus 5x plus 4 equals 0. And if people want to solve by complete the square, it takes like 5-10 minutes.
I know, it does.
On the other hand, if anybody knows how to factor, x plus 4, x plus 1, okay, this is x equals -4, x equals -1, I'm done, 10 seconds. So that's why having more than one method is nice. Quadratic formula, not bad, but even that takes like 30-45 seconds, this takes 10. So it's useful to have lots of different techniques and then look at it and say, oh, factoring, I know how to do that, done. Does that kind of make sense? So that's why multiple techniques are useful. So my question is, what happens when you're dividing by 90? Watch this. 29 divided by, well, let's tell you what, let's try an easier one. Let's try 5 divided by 90. Put a question mark. What happens when it, by the way, go ahead and type that in. 5 divided by 90, what do you get? 0.050505?
No,
Or
it's
0.055555? Yeah,
And it's 6.
0.05, and that's the calculator rounding off.
Still for 6.
Yeah, by the way, does anybody have a 6 at the end of that? Ignore it. That's the calculator trying to round off because it can't go forever. In other words, the calculator is wrong.
0.2.
Don't trust the calculator with your life.
A 6.
Listening?
Mine's wrong.
Now, question.
That's how the equation's wrong.
Versus 5 over 9.
Okay.
Let's focus up here. Let me tell me what 5 over 9 is. Should be able to be easy. Brendan, help me out. What's 5 over 9 as a decimal?
5 over 9.
Yeah, don't do it on a calculator.
As a decimal.
What happens when you put 9 on the bottom?
Well, I kind of just looked at it, so it's 0.56.
Guess what the calculator did to you?
My calculator's bad.
Your calculator lied to you. Correct.
5.
It's 0.5 repeating. 0.5555555.
Yeah,
We learned nothing yesterday.
the day before yesterday.
Yeah, it was
And Mr. Coffin.
All right, now look up here. Does anybody see a similarity between this and this? What is the similarity?
If there's a 0 after the 9, there's a 0 before the 5s.
Yeah, that's the only difference, is that there's a 0 in front of you. And there's a 0 here. Is there a pattern here? The answer is yes. Can somebody, math people, tell me what this answer is? What's 5/9 divided by 10?
Could you?
Figure it out.
Oh, it's
I'm not getting you out of this. You do it.
90 over
You got
5.
this. How do you get it?
You do the reciprocal of 10.
What is the reciprocal of 10?
1 over 10.
So let's do it. 5 over 9. Dividing by a whole number, you can always make it a fraction. Dividing by a fraction is the same as what again? Multiplying by the reciprocal. What do you get?
5 over 90.
5 over 90. Let me show you what you just did. Does everybody agree that 5 over 9 equals 0.55555, blah, blah, blah? Is everybody settled on that? Divide both sides by 10. Remember, you can do anything you want as long as you do it to both sides. This is a little creepy when you do this, because one side is a fraction, one side is a decimal. I'm just trying this as an experiment. Does everybody at least get settled that 5 over 9 is 0.5 repeating? That should be from 2 days ago. If you put 9 on the bottom, you make the top repeat. I'll see. Okay, memorize that. But dividing this a fraction by 10, we just did it. What do you get as a fraction? What's 5 over 9 divided by 10? Mary. 5 over 90. Can somebody do that same trick over here? Divide this by 10. How do you divide a decimal by 10? It's actually a trick you learned years ago. Go.
You move the decimal point over 1 space to the left.
To the left. What do you put in the blank?
A 0.
Really?
wow, Brendan.
Thank you, Gian.
If you want to delay a repeating decimal by 1 space, divide both sides by 10. If you want to delay it by 2 spaces, how would you do that? Divide by
100.
100. How about you divide it? Let's do a tricky one. How about you delay it 4 spaces?
10,000.
10,000, yeah. You divide both sides by a power of 10. Now the question still remains, why did we get this goofy number, 29 over 90 is 0.32? We were not expecting the 3 or the 2. Well, let's go back in time a little bit. 0.32 repeating is 0.3 plus 0.02 repeating. Does everybody agree with that?
Yes.
It's a little hard to see, but this is the 10th place and this is the 100th place, and there was a gap. They put a 0 there. 29 over 90. I still don't know what that is. Well, I know it's 0.32 repeating, but it's cheating. I used a calculator. Can anybody use the trick here? I mean, I know this is 0.3. Okay, math people, you had a worksheet on this. Rob, what's just 0.3? No repeating or anything as a fraction. 3 over 10, good. Because 3 over 9 would be repeating, and 3 over 10 is not. Can anybody tell me what 0.02 repeating is? 2 over 9 would be 0.2 repeating. How do you get it to delay 1? Go, Brent.
2 over 90.
2 over 90. To put a 0 at the end delays it with a 0. Okay, math people, can you add those? Yes, you can. You've been doing it for years. How do you add fractions?
29 over 90.
Yeah, you need to find a common denominator, like what? 90. What does this have to be bigger by? 9. Top and bottom. What's this going to give you?
27 over 90,
27 over 90 plus 2 over 90, which is what?
29 over 90.
29 over 90 is, ta-da! We just solved the magic problem, so to speak. Questions? Alrighty. There was one other thing I'd like to show you. Actually, two. One is a potential extra credit question on the test. This, by the way, is a true story. I was in college, and no, that wasn't the story. And I was in a math class with a professor who made this claim. And I probably should have heard this in high school, but for whatever reason I didn't. I think they taught it and I just spazzed out over it. So you're not the only one who ever spaced out over a math lesson. But that being said, does anybody know what fraction that is?
Oh.
9 over 10.
No,
That would be
9
0.9 by itself. Go, Rosie.
9 over 9.
It's 9 over 9. By the way, what's 9 over 9?
1.
That's 1. Does that bother anybody?
Yeah.
0.9 repeating equals 1.
What?
Wait, it does.
I
If
already
you-
knew that.
I argued with my professor for 2 weeks. I thought 0.9 repeating is a little bit less than 1. It just has to be, right? It's like, why write all the 9s if it's, 0.9 is less than 1? Yeah. 0.99 is less than 1. So a whole bunch of 9s is still less than 1, just by a teeny weeny weeny amount, right? And he said, wrong. 0.9 is exactly equal to 1. I think the problem he had was 1.9 repeating. And he said it was equal to 2. That just bugged me. There's something wrong with that. By the way, I lost the argument. I was wrong. It is equal to 1. I'll prove it to you in 2 different ways. 1 versus 0.9. What's the, let me scoot this down a little bit. 1 versus 0.9. Can we tell me what the difference is between those two? How far?
0.1.
0.1. Does everybody agree? 0.1. How about 1 versus 0.99? How far apart are they? I think money, it might be helpful. Maria, how far apart are these?
1.1.
You get closer. Think of this as like 99 cents and this is $1.
1.
1 what? If you're using money, 1 what? 1 cent. How do you write that in dollars?
0.01.
Yes, 0.01. Did we catch on so far? Eric, take over. 1 versus 0.999. How far apart are they?
0.001.
Got it. Andy, take over. 1 versus, you can probably predict what I'm about to do. How far apart is 1 from 0.9999?
1, 0, 0, 0, 1.
All right, now comes the main question. Blah, 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 blah. 1 versus 0.9 repeating. How far do the 9s go? Isabel. If it repeats, how far do the 9s go? Forever.
Infinite numbers,
They go
so you
forever.
can't-
You notice when I'm in the thousandths place, when there are 4 9s, I have to have 4 decimal places here. 3 9s, I have 3 spaces here. 2 9s, I have 2 spaces. 1 9, I have 1 space. How many spaces do I need?
An infinite number.
I need an infinite number of spaces. It's going to be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. When do I get to the 1?
Never.
Never. I never reach the 1. Because I got to get past an infinite number of zeros first. What happens if you have 0.0000000 forever and never get to anything else?
And y equals.
Guess what that's equal to?
0.
0. So what's the difference between 1 and 0.9 repeating?
0. This
0.
is.
There is absolutely no difference. It still bugs me in an emotional sense, but it's true. Actually, I'll tell you the question that actually, it wasn't quite, it didn't start like this. He asked the question, it was actually in is a class called topology, which I still have nightmares about. But it's there are probably people who are way better at it than I am. I actually dropped the class after like 2 weeks because like I do not understand what this man is saying. He's using English words, but I was like, what are you saying? So if you've ever had that experience, so have I.
So they drop out.
No. No. It was complicated to drop out for one thing. Well, there are two.
Oh, so
That's
you
not
wanted
for
to drop out the minute
Okay.
you started.
45-second story.
No.
The first class was called Advanced Abstract Algebra. I took beginning abstract algebra, loved it. It's basically you can invent your own algebra. It's like what would happen if you could invent all the rules for math? Could you do it and have it make sense? It's harder than you think. It's kind of like building your own car. Like anybody can build a car out of clay or something like that, but can you build something so it actually runs? It's tricky. So it's something like saying, the commutative property, the associative property, and things like that. If you could design your own property from the ground up, you could invent your own math operations. So instead of addition, subtraction, multiplication, division, you can invent your own.
Which ones did you invent?
I don't even remember. It was tough because you're trying to invent something that doesn't already exist.
That's cool.
And you had to invent a new symbol. It was like I think I remember it was. I think I used this. I just.
Yo,
So that was my math symbol.
That is the greatest symbol. That would be bright.
But then I had to define it. I had to tell people, what does smiley face do?
Smiles.
So it's this. It's basically, it takes, so A smiley face B does the following. It does A squared minus B squared over AB.
Oh, so you just had to come up with a formula and make it
Yeah,
make sense.
that's what this, it's sort of like on this new planet, this is what the addition sign does. It's a lot more complicated than our addition. But I had to find something. All the other stuff was used. And all these other people, everybody else in class came up with cooler ones than I did, although I had the cooler symbol. So 2 smiley face 5 would be 2 squared minus 5 squared
What she call this?
over 2 times 5, which is, I don't know, 4 minus 25 is negative 21 over 10. So 2 smiley face 5 gives you negative 21 over 10.
Yo,
Thank you, that's my function. Woo. Now, my question is this commutative? Can you switch it around and get the same answer? It turns out in this case, I don't think so. It's sort of like, the commutative property is like A plus B is equal to B plus A. So is 2 smiley face 5 the same as 5 smiley face 2? No, because you'd actually get positive 21 over 10 the other way around. So mine is not commutative. Darn. Is it associative? I don't even remember. I don't think so. Blah, blah, blah. You get the idea? Abstract algebra is like you can invent your thing from the ground up and then find out how algebra works, like in the very guts of it. I had a blast. Okay, that being said, so I went to second advanced abstract algebra, taught by a very different guy. The first lesson, I sat in the class, and I swear, he was using English words, and I think I recognized most of them, but I had absolutely no idea what he was saying. It was so scary. It was my first experience of listening to English. It's like I had forgotten how to speak English. It's like, is this supposed to be happening? It's like pretend like I woke up one day. It's like I had a nightmare like that once, where I woke up and I could only speak Spanish. Like I was in my dream, I could only speak Spanish, and I was listening, and I was in the United States in a place where they only spoke English, and I couldn't understand Mom and Pop because they were speaking English, and my brother, I couldn't understand what he was saying. It was scary. It's like, what do I do? I don't even know how to ask her to go to the bathroom in English. So like, this is really. I woke up. I was pretty scared. It felt like that. It's like I had forgotten how to speak English. It's like this. Everybody's speaking English, and everybody else was sort of. Maybe they were just faking like I was, but I dropped the class that very day. But out of here. Then I went to topology. I lasted 2 weeks in that one, and then I dropped that.
What
one.
is topology?
Ask somebody who understood it more than I did. I know. I'll answer that later. I do know a little bit more about topology now than I did before, but it was weird. It's a really weird site. It's fascinating once I didn't have to get graded for it. But anyway, But why did I do? How did I get off on this? Oh, right. Yes. But I finally got into a class, right? And it was in topology. This is the one good thing I took out of topology. He said, "What's the difference between 1 and 0.9 repeating?" Nothing. And that just bugged me. They asked the question, "What is the biggest number that's less than 2?" Sounds like an easy question, right?
1.
Like, what's the biggest? What's the biggest? What's that?
1.9 repeating.
What's the biggest number that's less than 2? A lot of people say 1, but you can use decimals.
1.9 repeating.
1.9, I can go to 1.99 and it's bigger.
1.9 repeating.
1.9 repeating is equal to 2. It's not less than 2.
1.98 repeating.
Ah, but I can do 1.998 repeating and it's bigger.
1.9 repeating and 8.
Good luck with the repeating and never getting to an 8. The 9s go forever and your 8 would be fall off the end of the earth, so to speak. Is that clear? Okay.
So it's the answer.
Oh, wait. Oh, did I have a question in here?
I have no idea.
What's the biggest number?
Oh, no. Well, no, what's the biggest number that's less than 2? There is no such number. Doesn't exist. You can always get closer. And the 1.9 repeating doesn't work because it's equal to 2. Yeah, of course.
You had another example for proving it.
Oh.
Yeah, you said you had 2
Yeah, you
examples.
too.
Oh, right. Yes. It's actually the technique we had over there. 0.9 repeating, I'm going to set it equal to x. There's no whole number part, so I can skip that step. Name the repeating part x, I already did, so step 2 is done. Multiply both sides to get past the non-repeating part. There is no non-repeating, so I can actually skip 1, 2, and 3. Multiply by a big enough power of 10 to get past 1 repeat. Looks like 10 would work. So 9.9 repeating is equal to 10x. Now subtract. Here, look over here. The repeats cancel. 9 equals 10x minus 1x is 9x. Divide by 9. That's this. It does still bug me a little bit.
And actually, what? This is weird.
I totally agree. Emotionally speaking, yeah.
But another one, wouldn't it, if you wrote it out like 0.99, if you just rounded? You kept
Rounding just changes the number though. Yeah.
And then you kept rounding, then it'll spill over the decimal.
Say again?
If you kept rounding it, like if you had a long list of nines and then you kept rounding the end one, so it went over the decimal.
Well, anytime you round it, you change the number, so it's no longer equal to the original thing. So I have one last lesson for you on that. There's lots of snow on the ground, so this would be good. Let's assume, by the way, does anybody know when is the only appropriate time to round in a problem, in a math problem? If you're allowed to at all.
When they tell you to.
Right, but let's just say you have a 10-step problem. When should you round off your answer if they allow you to round at all?
At the beginning.
If they say.
In the middle.
At the very end.
Oh, yes, that's what I said.
All the steps in between. Here's the example. I'm going to hire you all to shovel my driveway.
How much?
I'm going to $14.49 an hour.
Oh, okay.
Oh, wow.
And let's just say I have this. You also have to shovel the sidewalks around because they fine us if
Okay,
you
that's
don't.
easy. Well, I'll just sit there for a couple hours.
So let's just say
Okay, we're-
I hire you and you take 4 hours. So, according to this, I'm going to be totally lazy here. 14.49 times 4. You're expecting $57.96. That's a nice haul for shoveling snow. However, I said, hey, I'm a mathematician, just to make things easy, and you're a fan of rounding, right? So 14.49 is not quite halfway, so I'm going to round that to 14. Is that good or bad?
No.
That's bad. Oh, and by the way, 14 is not quite halfway up to 15, so I'm rounding that down to 10.
No.
That's not
That's
And by
not
the way,
fair.
4 hours is not quite halfway, so I'm rounding that down to 0, so you just shoveled my one for free. Thank you very much.
Messed up.
Rounding is bad.
Do that.
Seriously. Don't.
Do
By the way,
do that one day.
if I rounded here, look at the very end problem. We gotta let you go, but
I'm gonna do that one day.
this would have rounded to $58, which actually would have been a little in your favor. If you round at the very end, that's the only appropriate time to round any math problem ever.
Well, if you
Okay.
rounded it at the beginning.
You rounded at the beginning. I did.
Well,
To
if you
round,
rounded
and that
it
rounds
up,
down to 0 because
you
it's
rounded
less
it
than halfway to 100.
At the beginning.
Please stand. There's no additional homework.
Let's
You
go.
might have predicted it. Don't get used to it. Up you go. I wish. They were on my desk when I got landlocked in the ice storm. So, yeah. That's another reason why I didn't give you homework. Let's pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. So me, if you're listening at home, one day off of homework. Hope you enjoyed the chaos up here. Talk to you later.